All right, well, here you go, Mark.
Thanks, George. I am super excited to be here. This is my first time up on stage, so I kind of thought since we put our presentations early that there would be a presentation ready to go, but apologize for the delay there. So let's get started. This talk will be on leveraging Mikrotik in the cloud for fun and profit. If you raise a hands, who has not built a cloud-hosted router yet? Awesome. So this talk is half for you. The other half will be hopefully sparking imagination on what else can be done. But if you haven't done it, I hope you'll right now, if you got your laptop with you, go create a Amazon login if you don't have one. And literally you can walk through this. It's super, super duper easy. One of the easiest things to do. If you don't want to follow along here, obviously this video will be up on YouTube, but you can also, there's a wiki on it in Mikrotik, and you can go step by step and get it done. So again, this is going to be a workshop. I'm going to talk about how to build a CHR in the cloud. I'm not going to talk about areas more than what's already been talked about. If you want to stop by our booth, we're next door. I'll be here until the mum closes. So I'm going to just talk about who I am. We're going to talk about why you might want to build a Mikrotik in the cloud. I'm going to show you how to do it with our workshop. Afterwards, I'm going to cover a couple of example use cases and then one case study, which is just how MCP Networks uses Mikrotik in the cloud to deliver our service. So again, I'm a prior life network engineer. I worked at an ISP serving 50,000 subscribers in North Dakota. I discovered Mikrotik in 2009 and fell in love with it immediately, but didn't see a use case that really made sense to me for a couple of years. And then once I started discovering use cases, I never stopped. And it just got better and better and continues to get better to this day. So I'm a certified trainer, MTCNA, traffic control engineer. I've got certifications with other vendors and computer science guy. I also program code. I'm a server guy. I can talk about any of that stuff. Anybody who wants to have a conversation, I hope you'll connect with me on LinkedIn, Facebook, grab a business card. Let's talk. So why put a Mikrotik in the cloud? Well, the number one reason in my book is because we're all very good at monitoring our own network, right? And you're able to see from your perspective how things look on your network, and nobody else can do that better. However, having worked for large ISP, there are times when you've got one-way traffic problems. There are times when something's not working right, and you have no way to discover it because all of your sensors are within your network. And so when you have an internet problem, what's the best way to tell that? It's when the outside in can look at you. So I argue that the best reason to have a cloud-hosted router out in the cloud is so that you can look at your network from a different perspective and get that idea of what the health of your network looks like to the rest of the world. So additional reasons you might want to use in the cloud: throughput testing, proof of concepts. A really compelling reason is if you've got critical servers in your infrastructure and they're physical, I highly argue that you should put some redundant servers out there that are in the cloud so that if you have a failure and you've got business critical customers that have multi-path to the internet, either through you or through competitors, you can also offer your services as a redundant service that's got an extension of your data center out there. And finally, I guess, the first time I did the cloud-hosted router on AWS and it was working and I was able to log in, I mean, I just had that tingles and it was just exciting. It's just like, hey, the world is my oyster here, and it's freaking cool. So how do we do it? Again, if you've created an account, you've got almost the hardest part done already. This is not going to be quite as easy as clicking next, 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 but almost, very close. So I'm going to walk through the steps here. I'm going to tell you some tips and tricks on the stuff that I know. And then some of the stuff I'll tell you, it's very advanced and we're not going to go into that during the talk. But so to start with, you find EC2, which stands for Elastic Compute. With Amazon, again, you signed up for an account. If this is new to you, you get to do some of their services for free for a year. So if this is new to you, go ahead and click on EC2. There's a free tier of instances that we're going to talk about. You can run this stuff in the cloud for a year for free. After that year, you're going to pay for bandwidth, storage, and CPU that gets used on EC2 instances in particular. So literally, we go, hey, launch an EC2 instance, and it's going to take you to what they call the AMI marketplace. AMI stands for Amazon Machine Image. And it's basically, if you've worked with VMware before, we're just picking an operating system to go on this virtual server that lives out in the cloud. So what's awesome, Mikrotik already went and put these images out there for us. A couple years ago, when CHR was brand new, we had to get user contributed stuff. It's already out there now. All you got to do is click the search button, type in CHR, it'll come up. Some of those ones that were user contributed are still out there, but they're older code. You might as well just use the one Mikrotik provided. So now we got instance size. The awesome thing about Amazon in the cloud, right? If you spin up your own router on your own hardware, you are going to spec that out. If you do that in Amazon's cloud and you decide, hey, this box is too small, right? We're going to pick T2 Micro because it's on the free tier, but you can go tier 2 Nano, and it's just about how much you're going to pay monthly and how much horsepower is available under the hood. And they have, Amazon serves everyone from test labs all the way up to global companies serving millions of customers. And you can buy the size that you need from micro, nano, small, medium, large, double extra large, 16 extra large, and at speeds of anywhere from a couple hundred megs up to 20 gigs. One note, just before I move on here, if you use the instance that's free, this is not a well-known or published fact, you'll get about 200 megs of bandwidth throughput. If you want more than that, you're going to have to upgrade that package. And so upgrading that package is as easy as shutting your instance down, telling it that it's a new package size, turning your instance back on again. So on the network side, this part is super, super awesome, and I'm not going to talk a whole lot about it. The main thing you need to know, you're going to get a public IP, you're going to get a DNS entry, and if you look further into AWS, they brand name everything. And so confusing for me for a long time is that elastic IP means static IP. But in the same way that Mikrotik has a very, very robust and flexible operating system for providing networking services, AWS has a similarly robust, they've got a firewall built in, they've got virtual networking built in. So you can build a virtual network and virtual data center. You can use the cloud-hosted router to be your VPN concentrator, to be the gateway for your virtual cloud-hosted servers that might be an extension of your data center. So doing that is not going to be covered here. That's all I'm going to talk about it, but you can do that, and it's pretty cool. So storage. With your free tier, you get 30 gig. It automatically fills in 8 gig. You can go ahead and change that there and then move on to the next step. If you need more than that, go ahead and plug that in, but free tier includes up to 30 gig. As you see, we're just basically accepting the defaults in most cases and hitting next. So again, super, super easy to do. One of the last steps here, you want to tag all your instances. In the first case, when you build one instance, it's no big deal. You don't have that many showing up in your list. But as you build more and more instances, it's super useful to know that, oh, this is my cloud-hosted router versus this is my web server. So at least stick a name on there and tell it what it is, because otherwise, much like your Android identification discovery on your network where it says Android dash blah, 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 you're going to get some bunch of letters and numbers as the ID of your instance, and that's not so useful. So we're almost done here, and how about security? Well, the first time I did this, I was very concerned that, hey, I'm spinning up this cloud-hosted router. It's not going to have a firewall on it. I'm going to get owned in like 10 seconds because this thing's got a public IP. It's wide open on the internet. What the heck? It opens 22, right, SSH to the world, but the deal is you're going to have to create a key pair. And if you're not familiar with this, this can be the most cumbersome part of the process. So we're going to walk through that. And if you're a Linux or Mac user, this part's easy, right? You generate a key pair. It's associated to your instance, and you download that pair. You just, in your SSH command line, append the key to your SSH command, and you'll be able to log in. If you're using Windows, there's more steps. One thing of note here is that you can use one key pair across all of your Amazon instances, or for additional security, you can isolate the keys so that each instance has its own key, or each group of instances has its own key. So again, if we're using Windows, you're going to have to go and take one more step. And the deal with that is that I'm going to talk about Putty. If you use a different program, there will be a different process. Also on Mikrotik's wiki, they cover some of these processes, and they have it for Putty. I think they have it for another SSH client. Your mileage may vary. It'll be slightly different for you. But if you want to use Putty, it's a free download. Just go Google search for download Putty, and this is an SSH client. And you'll also need to download the program called Puttygen. Two things to note here. It takes just literally like 20 seconds to click next, 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 next. Then it'll take about 5-10 minutes tops to spin up your instance. So what'll happen is that you'll see there in red, we've got this initializing state. It'll be in that state for a little while, and then it'll go to operational. And the things we need from this screen are either the DNS name of this instance or the IP address. You can use either one. So how do you get your Putty able to talk to this? Because by default, Putty will not do the automatic translation of the private key signing. So again, in Mac and Linux, you just append it to the command line. In Putty, we fire up this Puttygen program. You click two buttons. You click load, and you navigate to the place on your drive where you stuck that private key that you got from the Amazon page. And then you hit save private key. Now, once you save the private key, you shove it into Putty here under the SSH auth section, and you plug in the IP or the DNS name that you want to attach to, and that's it. We just now spun up a router in the cloud. Congratulations. Awesome. So things to consider now are that, yeah, we just spun up this router that's out there in the nether, and it has no security, right? It comes by default with, there's no firewall, there's no NAT. We're wide open on 22. So one of the first things you probably want to do is Winbox in here. I'm a fan of both CLI and Winbox, but if you prefer one over the other, if you're just going to SSH, you're pretty much done. If you want to use Winbox, I highly recommend doing the following process, right? Find out what your public IP is right now today, and maybe that's because you're connected here over Wi-Fi, over LTE, whatever. And again, Amazon has its own firewall that gives you an additional layer of security, which is super powerful and flexible, right? So I can protect my services and my routers in the cloud at multiple layers because I can do it on the Mikrotik itself and then the additional layer through Amazon. So find out what your IP is, go into Amazon's control panel. There's a section called security groups, and it's the firewall. It's got input rules, output rules, and we can add your IP for the moment in time that we have today here. You can go in, make access changes to your router, cloud-hosted router, while you're on the fly, while you're on the road, while you're at the office. And then when you're done, rip that out of Amazon, and it's a pre-firewall before even getting to your cloud-hosted router. All right, so we built a router in the cloud, and great. Maybe you're excited about that, maybe you're not. Why does that matter? Well, the first use case that makes sense to me is that if you're using Mikrotik already and the dude is free, right, let's spin up the dude. So all you need to do is go in and enable the dude service, and now point some devices at the dude, point the dude at some devices, discover them, and boom, you've got the dude monitoring your stuff off network, right? Awesome. We can do bandwidth tests, remote polling, build the charts, have the whole network maps. If you have an environment where you're all in one entity, maybe all in one city, whatever, maybe this doesn't make a ton of sense. But if you've got a span of control that is diverse, right, and maybe crosses different parts of the country or different cities, it might make more sense to monitor this off-site than on-site, because you can get that visibility on what the health looks like from outside of your network instead of from the inside. Next up, we got lab environment, right? If I want to prove code on, Mikrotik, this code version versus that code version, or talk about a protocol, I need to look and see if my OSPF redistribution is going to work with BGP, etc. Maybe I want to learn OSPF. I can spin up a couple cloud-hosted routers, have them talk to each other, and now I can packet sniff, and I can look at what the actual interaction looks like, check the log messages, and you can do this. I'm going to talk a lot about augmenting, right? Because doing this isolated, right, you could just do the same thing in your lab. But I like the idea of augmenting my lab with a cloud router that's sitting out there, and it's more real-world environment, right? Because now you're exiting your network, you're crossing the internet, and now you're getting some real-world exposure to how things are going to behave out in the wild. Finally, you can do some testing with other vendors we've had in the past. You've got Cisco, Brocade, Juniper, etc., and you need to see how this is going to work, and maybe you've got something on site. Maybe you just want to spin an instance up in 5 minutes and have it point there. So VPN Services Gateway. This is one of the things that MCP Networks does to enable areas to work, and I believe that the earlier talk today, they're absolutely doing cool stuff with VPN concentrators that are changing usernames and passwords on the fly. That's super awesome. I was excited to hear about that. But anyway, if you want to centralize off network your VPN concentrator, you can do so with a CHR. Like I talked about before, let's say you've got the physical data center and you want to have those services highly available. You can do that by having redundant services on premise, but that doesn't give you geo redundancy. You want to add geo redundancy? I think there's a compelling reason to do this in the cloud. The cost of spinning up the instance is very negligible. It's almost nothing. And then you're just paying for what you use. If you, I don't need to pitch for Amazon, but hopefully you can recognize that this is a low-cost way to have additional redundancy, additional capability, visibility, and services available that are off-net. One of the things we do is use our cloud-hosted router as the AWS gateway. So we talked about the VPN concentrator. If you're going to fire this up and have it be secure, right, you're going to put some IPsec on there. What's awesome is that the IPsec can happen right here on the cloud-hosted router. Amazon also sells their own branded gateway, and you can buy that and do line rate 1 gig, 10 gig. But if you're doing a smaller instance, if you're just hooking this up to your lab, or you don't have the full gig requirements, spin up your cloud-hosted router and use it as your gateway for your servers that live in the cloud, and he can do that IPsec at a much, much lower cost. We use backup system in the cloud, so absolutely, once you've built these servers and you've got this framework in place, I highly recommend that you do off-site storage of your backups, and this is a way to complete that process. So I think earlier you heard about API, and that's absolutely what we're doing for our company and our product. So Aries is an app for your smartphone that gives you a remote control for your home network. And the way that works is that you fire up the app, it talks HTTPS to our servers in the cloud. Firewall on our AWS instance allows only port 80 and 443 to our web servers, and then those servers turn around and talk Mikrotik API to the CHR. And then the CHR builds secure VPN tunnels to each individual customer, subscriber, premise, and equipment. Why is that awesome? I mean, you talked about it earlier. We can scale. It makes it so that you can automate, and this is done in a secure way. So I think it's almost time for lunch. I want to just burn through that because I want to leave plenty of time for Q&A. If you have anything you'd like to talk about, I hope you'll meet up and talk to us at lunch or stop by our exhibit booth where we've got areas on live demo. We're ready to talk to you about that if you want to talk about product. If you want to talk about this presentation, give me any feedback on that, or just talk about cloud-hosted router, anything that maybe didn't make sense, come talk to me. Again, thanks for attending the MUM.